It is like this. Now where is the rod? Let me bring the rod. Keep it rod like this. Now finally the rod has become horizontal. Release theta equal to 0 is telling. So here the bob, they should be in contact with the inner wall. Yeah. This is the position in which they are released. You see, no? What will happen to them? Let this be radius r, radius r. We know this length L. Now also it will be length. It will be symmetrically about this particular point. This is 2m. This is m. They are released from rest. Now when they arrive, so here this will have a speed v. This will have a speed v. They should have a same speed or different speed. First primary question. Anybody wants to answer?
Same speed.
Because the rod, no, the length of the rod should not increase or decrease. The velocity of the ends along the rod must be equal. So therefore they must have same speed. We'll take this as, say, some angle phi. He's asking only that speed v. So this should be the 2m. This should be the m. How to calculate that speed? Decrease in potential energy of this particle 2m should be equal to increase in potential energy of this particle m plus kinetic energy of these two bobs. How much potential energy of this will decrease? So we have took this angle as phi. This is r. So this should be r cos phi. So what is the height it will descend? R cos phi. This height is r cos phi, no? Because this is r. So what is this height now? R cos phi. Then it has ascended height. How much? R minus r cos phi. Call h. So what is h? Should be equal to r minus r cos phi. Now we'll write down the equations. Decrease in potential energy. 2mg r cos phi should be equal to increase in gravitational potential energy of the other bob. mg h plus mv square by 2 . What is h? H is r minus r cos phi equal to, this will be 3m v square by 2. M get cancels. So this will be 2gr cos phi equal to gr 1 minus cos phi 3 by 2 v square. We don't know phi. What to do with phi? Anybody answers how to bring the phi? L by 2, L by 2. What is cos? What is sine phi? L by 2 by L. And what is length L should be equal to? R root 2. Check it now. L by 2R. This should be equal to R root 2 by 2R. 1 by root 2. So phi will be 45 degrees. That will substitute here. 2g r. Intentionally they are not given that length of the rod. From the diagram we are supposed to calculate. Solving this will get the required answer. Okay, nothing to do. Conservation of mechanical energy. Sir, I want to write some normal contact. How much is there? Yes, go. Come on, right now. Who is stopping you? So there's a normal reaction. Call N2. What is the normal contact? N2 minus 2mg cos phi equal to mv square r. N1 minus mg cos phi. They will have same normal contact. Check it, N1 and N2. They may ask you all these things. Find the normal contact, everything. Or they'll ask you find the tangential acceleration, centripetal acceleration of the particles here. Is it okay this, or anybody wants to say, sir, how it is possible? I want students to make observation. Intentionally I brought this. Is it agreed this, or anybody wants to object? Anybody wants to object this? What make this particle to move? The rod only, no? So continuously this rod will be pushing it. Continuously this rod will be pushing it. This rod will be trying to oppose. So there's also reaction force in the rod. Then how come you apply conservation of mechanical energy, sir? We don't agree with this. This should have been the question from your side. The net work done by the reaction force in the net work done by the force set up in the rod. Okay, there's some force will act here, no? Because you see that one. The weight of this will act along the rod. So the rod will push this particular bob, then only it is able to slide up, no, otherwise how it will move. So therefore there will be some force is set up in the rod. Don't call tension, because the tension is set up in the string. In the rod we should not call tension set up in the rod, force set up in the rod we should not call tension. To make you understand, let me call tension. A tension is set up in the rod. The tension, what happen, will push the block. So then work done by tension should be there. Net work done by tension in fact will be 0. There is a reason why I am able to apply conservation of mechanics. What about normal contact? Normal contact will always act perpendicular to displacement. So therefore what is the conclusion here? Work done by normal contact work done by tension also 0. What is T? T is the force set up in the rod. I think we have to be very careful here. Huh? What is the T? T is the force set up in the rod. What is the work done by this force? Will be 0. So now at this particular point we have to show that also here it is acting like this. Now I think things will change. Will you make any changes here? Component of tension should also act here, no? This will be fine. This will be fine. T sin phi will come. Very important in exams. Definitely they will trouble you with all these things. Huh? You have to be very careful. N2 should be 2m, no? Yeah. You have to be extra alert. Write it down. I'll slide down. String, like a force set up in the string, tension it